All right, so today we're going to go over the basics of electricity, what it is and why it is, and why we might have a benefit for it. So electricity is basically the flow of a very special particle. It's not particularly that special, it's all over the place. They're called electrons, they're part of an atom. They're the outer portion of an atom orbiting around the core, or the nucleus. And those little particles will flow past other atoms through anything that will conduct them, that you can carry those electrons through. And by having that flow occur, we can do some work. We can light some lights, we can run some motors, things like that. That's basically what current is, electrical flow. Now, in order to get these electrons to flow, and remember, we're just doing a recap here. So in order to get these electrons to flow, we have to have some sort of a push. You got to push these things to go. You have marbles on a table, you're going to give them a little shove. In order to do that, you got to push it. That's going to be called voltage or pressure. And it's named after a guy, which, you know, he's been recognized enough. We're not going to go over that here. So we call it voltage or volts. So you apply a pressure to some electrons to get them to move. That's called voltage or volts. Okay? Clear so far? I'm going to check with somebody here in the room.
Yep.
Excellent. Okay, the next thing I think we should go over would be what might slow that flow or keep it from going entirely, and that's called resistance. That's something that's stopping that flow from occurring. So electrons want to move through. We're applying a pressure, a voltage. We're trying to get this current going, and there's an obstacle for that current to flow. That obstacle is called resistance, and it can be a greater or lesser amount. It can be very little, in which case a lot of flow can happen. It can be a great deal, in which case very little flow can happen. Make sense?
Mm-hmm.
Excellent. And then we want to talk about load. Load, what is load? Well, that's what we're trying to run these electrons through to get some work done. So if we're pumping electrons, we're pushing them through with some voltage, and you got this flow of electrons going through something like a light bulb. Now we'll see, oh, the light starts to light because those electrons are jumping through there and it's going, whoa, check it out. And it's starting to light up. That's called a load, the thing we're trying to run. Now, technically, anything, any kind of resistance in that path would be considered a load. It's going to generate a certain amount of heat and stuff like that just from having resistance and slowing down this flow. And that would all be called a load. But the main thing we're worried about in electrical, when we're dealing with like buildings and wiring circuits and things like that, is we're worried about the thing we're trying to operate, the thing we're trying to make do work for us. And that would be a motor, a light bulb, something like that. So that's what we call a load. And it can be anything. I mean, look around your house, look around the office here, anything like that. You'll find things that are, you know, the coffee machine is a load. The light fixtures are loads. The pencil sharpener is a load. All those things are loads. And they all require a certain amount of energy to operate properly. So we have to have a certain amount of push, voltage, and a certain amount of flow, which will get the work done. And that's it. Okay, so when we're looking at these electrical flows, now we've just gone over the basics of what's happening. And really, if you just look at, it's always a flow. That's what we're dealing with electricity. We're worried about flows. You'll hear people talk about, oh, there's this, what if there's just electricity there and there's no flow happening? Well, why worry about it? You know, now we're getting into silly stuff. It's like, we're interested in the flows. What's happening? That's what we want to control. That's what we're trying to get factories moving and stuff like that. That's what we're trying to do. Get lights on so people can work, get machines running. So we're interested in the flows of electrons, not whether or not they're static or blah, 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 blah. Okay, everybody good with that?
Mm-hmm.
Okay, so now let's look at the fundamentals of how this is all put together. So I'm going to go to this board here. Pardon me for my spelling. I will write very little, but I'm going to just more do a sketch of, here is, we're going to call this a source. And I'm going to add letters and stuff as needed. So that's the power source. That will give us power. This will apply voltage to the system. It'll have electrons available, and it'll have wires that also have electrons available to flow, okay? So right now we're going to have some pressure going this way, right? It's going to be pushing on that wire. So as it pushes through this wire, it goes over here too, and we're just going to call this a load. There's our load, okay? So the electrons flowing through here will flow through the load. Now, they just stopped. There's nothing here. Oh, well, we've got to come back to the source. So now we have, it's like a pump. This thing is pumping electrons this way, and then it's sucking them back this way. And it continues to do this cycle, pumping electrons through this, and this light bulb lights up and glows. This we call a circuit. You see how it's a circuit. It loops from here, from a starting point, goes all the way through, and it comes back to that starting point again. And inside, it's actually going through there and going back again, doing it again. It keeps repeating. Now, this can be a battery, it can be a generator, it can be anything like that. But that just, keep it simple, it's just a power source. It's creating a pressure, a voltage, to push electrons through this circuit, and that's it.